The last piece for this chapter is looking at arcsine, arccosine, and arctangent and solving for another trig function given 2 of 6 different possibilities. So between cosine, sine, tangent, arccosine, arctangent, and arcsine, I'm going to combine 2 of those together. And can I find the answer of combining any of those 2 together? So we're going to do a little quick reminder. Arcsine, arccosine, and arctangent have the exact same relationships as sine, cosine, and tangent. Remember, arc is just saying what angle created that measurement. So arcsine is still going to be opposite over hypotenuse when we set up our reference triangle. Arccosine is going to be adjacent over hypotenuse. And arctangent is opposite over adjacent. So those relationships are still the same. Now I want to find the cosine of the arcsine of 24/25. And here are the 4 steps we're going to go through. First, we're going to start the innermost trig function and determine what quadrant we'll be working with. So here arcsine is my innermost function. And arcsine is only defined in quadrants 1 and 4. And since arcsine is positive, I've got to be in the first quadrant, since sine is negative in the 4th quadrant. So arcsine is going to be positive in the first quadrant. So I'm going to draw my reference triangle just in the first quadrant. Step number 2, draw a reference triangle with the sides filled in with what we are aware of. Here we know that sine is the opposite over the hypotenuse. So the opposite would be 24, the hypotenuse would be 25. Step 3, find the remaining side of the reference triangle. So here, this is actually one of your Pythagorean triples, 7, 24, 25. And if you didn't know that, you could use Pythagorean theorem, saying up x squared plus 24 squared is equal to 25 squared. And you would get x is equal to 7. And the final piece is answer the question by finding the relationship of the outside trig function. Originally, I was asking for the cosine of the arcsine. Now that I've got this entire triangle set up, I know the cosine is the adjacent over the hypotenuse. So the cosine of this triangle is going to be 7/25. So once I've got my innermost trig function simplified, I'm then going to go to the outer trig function to simplify. Question number 2 here, the cosecant of the arctangent of -12/5. Well, if we start with our innermost function, we're dealing with arctangent, which is in quadrants 1 and 4. And arctangent is negative in the 4th quadrant. Because tangent is positive in the 1st, negative in the 4th. Arctangent has the same relationship. We also know that arctangent is opposite over adjacent. So we'll set up our reference triangle, and this time we're putting it in the 4th quadrant. And the piece that I'm giving is the opposite over the adjacent. And since we're in the 4th quadrant, the y value is what's going to be negative. I need to find the last side of my triangle. Once again, this is a Pythagorean triple. So it's a 5, 12, 13 triangle. Remembering the hypotenuse is always positive in these problems. And then finally, we know the cosecant is going to be the hypotenuse over the opposite. So once I've got this triangle all filled out, I'm done with the innermost part, and I'm only working with the outside. So the cosecant is the hypotenuse over the opposite, which is going to be 13 over -12. The third example, sine of the arctangent of x. This one I'm going to limit myself so that x is going to be between 0 and 1, which means I'm going to be in the 1st quadrant. Now when I look at this, I might think, I don't have enough information. But actually I do. Right here, this x is understood to be on top of a 1. So now I've already stated that the arctangent is going to be positive. We're going to be in the first quadrant. Tangent, we know, is opposite over adjacent. So my opposite will be x. My adjacent would be 1. And then I would use Pythagorean theorem to find out the third side. A squared plus b squared is c squared. 1 squared plus x squared is c squared. C is the square root of 1 plus x squared. So there's my third side. The last piece, now that we've solved the arctangent, is we want to find the sine of this value. We know sine is opposite over hypotenuse. So there's my relationship, x over the square root of 1 plus x squared. If you want to rationalize it, you can, but it is not necessary. The last one, I'm also going to put the condition that theta is in the first quadrant. So that means I can start right away by drawing my reference triangle in quadrant 1. Once again, this is understood to be over 1. And sine, we know, is opposite over hypotenuse. So my opposite is x minus 1 over the hypotenuse of 1. And I want to solve for my adjacent side. This one's going to take some time working with Pythagorean theorem. A squared plus b squared is equal to c squared. I'm going to solve for a. And I've got that messy situation right there. So a ends up being the square root of 1 minus x minus 1 quantity squared. And now that I've got all those sides, I've solved the innermost part. Now I can work on the outside. The secant is the hypotenuse over the adjacent. Which means I've got 1 over the square root of 1 minus x minus 1 quantity squared.